Good morning, this is Kasturi De. Again today, I've come to discuss the question answer section of this energy chapter according to ICSE syllabus class 8. Okay, so I'm starting with give an example to show the conversion of potential energy to kinetic energy when put into use. Okay, see, a stretched bow has potential energy. We know a stretched bow has potential energy because of its stretched position. This is because of this stretched position, the stretched bow has potential energy. And when the stretched bow is released, the potential energy of the bow changes into kinetic energy. Okay, the stretched bow itself has potential energy of its stretched position due to its stretched position, and when it is released, the potential energy of the bow changes into kinetic energy. This kinetic energy does work on the arrow and helps it to move. Okay, next question is state the energy changes that occur in watch spring while it unwinds. As the spring unwinds itself, the potential energy changes into kinetic energy. This kinetic energy does in moving the arms of the watch. Now give reasons for the following. No work is done if a man is pushing against a wall. See, when a person is pushing against a wall, it's very obvious that he is not able to push the wall. Okay, so because the person doing this, he does no work if there is no change in position or no motion of the wall, even after the application of the force. So, a man is pushing against a wall is not able to move the wall, so no work is done. Next, hammer drives a nail into the wood only when it is lifted up and then struck. See, when the hammer is lifted up, it has potential energy. At high position, the hammer has potential energy due to its weight and height. But when it is raised to a height, its potential energy increases. Okay, due to its weight, it has its potential energy. But when it is raised to a height, its potential energy increases. Now, when the raised hammer is made to struck on the nail, the potential energy changes into kinetic energy. And this kinetic energy helps the hammer to drive the nail into the wood. Okay, that is downward with great speed. Now, a horse and a dog are running with the same speed. Which one of them has more kinetic energy than the other? A horse has more mass than a dog. Since their speed is same, therefore kinetic energy of the horse is more than that of the dog because the mass of horse is more and kinetic energy depends on mass as well as speed. So speed is same but the mass is more. So mass more, kinetic energy more. So horse has more mass, more kinetic energy. As more is the mass, the kinetic energy is more. Now a teacher moving around in a class is doing work, but a child standing and reading a book is not doing any work. When a teacher is moving around in the class, he or she is displacing himself or herself due to the force applied, so work is being done. But when a child is standing and reading a book, he or she is displacing is himself or herself with the force applied. He is not displacing, so there is no work done. Okay, so one is standing there without moving, without displacing himself or herself, standing and reading. Therefore, what happens? There is the person who is standing, the student who is standing and reading, there is no displacement, so no work is done. But when the teacher who is moving around the class and dictating, teaching, etc., so he is displacing his position, his her position. That's why there is work done. Then state the energy changes in the following cases. A stretched bulb, an electric bulb electric energy changes into heated light, heat and light. An electric oven, electric energy to heat energy. A loudspeaker, electric energy which is received from the signal of the microphone and changes to sound. An electric motor, electrical energy to mechanical energy. Now, in the energy spent or on thinking, is the energy spent on thinking or talking a kind of work? Okay, give reason for your answer. See, spending in energy which is spent in thinking or talking, there's no work done as there is no displacement or any kind of motion being occurred due to the force applied. So, thinking or talking, no work is done, no energy is produced. State two examples when a force acting on a body does not do any work. For example, if we are pushing a wall and it does not move, then no work is done. Another example is if a boy is carrying his school bag on his back and standing there without any displacement, there is no work is done. He's doing no work. By giving an example, state and explain the law of conversion of energy. When a brass bulb is suspended from some support with the help of a string, like a cotton thread, it's a pendulum. Okay, it's an example of a pendulum. The pendulum is pulled to a position A to a height, say h. The height should be h, and therefore on one muscular energy is stored in the form of potential energy. Okay, then the pendulum is released and the pendulum moves from the position A to B. Its speed goes on increasing on height and height goes on decreasing. Therefore, the potential energy of A changes into kinetic energy till at B, all the potential energy changes into kinetic energy. Kinetic energy is so much that the bob is pulled to another position, that is C. Then here the kinetic energy slows down, and then it changes into potential energy. And at C, what happened? The pendulum will have the maximum potential energy. During the reverse motion from C to B, the potential energy again changes into kinetic energy. Similarly, from B to A, the kinetic energy changes to potential energy. And therefore, it is concluded that potential and kinetic energy are interconverted. Potential energy and kinetic energy are interconverted. As all the forms of energy can be put under the heading of either potential energy and kinetic energy, we can define the law of conversion or conservation of energy. Therefore, the sum total of energy in the system is a constant quantity. It is neither be created nor destroyed, but either energy can change from one form to another form. See the example of this pendulum, freely oscillating pendulum. See, from the S, the bob is suspended with a thread. This is the A position with the height. Okay, and when the bob is released, it comes to B. At A, there is the maximum potential energy. Then when it comes to B, it changes to kinetic energy, maximum kinetic energy. Here it is. Then it moves to, with that kinetic energy, it moves to C, with where it gets maximum potential energy again, and it comes back to B. Like this, it freely oscillates. Now, state the kind of energy, potential or kinetic or both, in case of the following. A flying mosquito. A flying mosquito has kinetic energy. A wound up spring of a toy car that has potential energy. A speeding car that has kinetic energy. Okay. Now, what kind of energy changes takes place in the bodies of living beings so as to produce mechanical energy? See, some solar energy falls onto the earth. We know solar energy falls on the earth. The ultimate source of energy is solar energy. On earth, some of the solar energy is changed into chemical energy by photosynthesis and stored in the carbohydrate molecules in the plant cells. Excuse me. When a human or any other animal eats that plant, or when a human or any other animal eats other animal which has eaten that plant, The chemical energy which is stored in the plant or the animal which has eaten that plant moves to the cells of the human body or the body of the other animals which has eaten that animal, okay, which has consumed that plant directly or indirectly. Now, all the body processes like digestion, pumping blood, circulation, that is, breathing, etc., all are powered by the cells which convert this stored chemical energy into work and heat by respiration. Okay, by respiration process, it changes the stored chemical energy to work and heat, which takes place in every cell of the body. Now, inside the muscle cells of the humans or any other animals, the chemical energy is changed into mechanical energy and heat. The muscle cells only, this chemical energy changes into mechanical energy and heat. Okay. Give an example to show that heat is from mechanical energy. When we cook food in a pressure cooker, by placing it over a stove, the heat energy changes water to steam. The steam in turn lifts the weight of the top of the lid and whistles. Okay, this lifting up of weight suggests that heat is a form of energy which is capable of doing work. Okay, so I'll stop here. I'll continue with the rest of the question answers in my next video. Okay. So please go through this. If you have any doubt, please do write in the comment box, and hope you are liking the videos. Press the like button if you liked it and share with your friends and colleagues so that they can also be benefited from these videos. And if you are a new viewer to my channel or not subscribed yet, please do subscribe to get the notification of my next video. Thank you.